Relevance of fresh concrete in the properties. Now the properties of concrete, especially basically what we are interested in the flow or workable concrete rather we can say. Now when you are producing from your concrete from your transit mixers, distance is not much different. Time is more important because sometimes heavy traffic, even 2-3 kilometers, it takes half an hour. And if you run travel by highways, you can cover even half an hour. You can cover about 20-30 kilometers. That depend upon the. So your workability basically what we are interested to time. How much time you required to travel from batching plant to your site. From site again, it has to be placed with various means. Now here we are to placing with pump. Now pump has got various capacities and what height it is pumping and depend upon your placing capacity. Maybe pump are designed to have a 40, 50 or 60 cubic meter per hour. They can place the concrete. But that much concrete we are able to place at site with the available equipment and manpower. That one has to understand. So 1 6 cubic meter concrete sometimes may take 20 minutes, sometimes may take 1 hour also. So traveling time may be 2 hours. In the placing, you need about say 1 hour. So we need workability up to 3 hours, 180 minutes. Now, same concrete or grade when you are using in roads or by the dumpers, you can directly unload onto the subgrades. So their placing rate is high. But you have to understand whether this has to be properly placed, compact and finished within the certain time that one has to see. And accordingly, you decide the your time after producing concrete, how much time required for transport, then placing arrangements, and what cubic meter they can place and finish the concrete. Now this also depend upon the temperature, what temperature you are traveling. Now the ambient temperature may be 35-37 degree. If you go to winter, it may be 25 degree. If you go to Delhi, maybe it's a 10 degree temperature. So that also influence on the loss of workability of concrete. That one I also remember. So the admixture what we are using, which is suitable for winter, may not suitable for summer. Even concrete which you are supplying in daytime, maybe from 10 to 3 or 10 to 4 p.m. And if you supply concrete at the night, your admixture doses will definitely will change because ambient temperature has reduced. So all this point one has to keep in mind whenever they are designing the concrete or they are demanding from RMC, we have to specify them. We have to give them, okay, these are our requirements, strength requirement, quality control is where your standard deviation, all these things will come. Then maximum size of aggregate depend upon the spacing of your reinforcement and workability requirement at the placing point, not at the receiving end, placing point. In the sense, I may get the flow here, but once it is reached here, after half an hour, maybe flow is not there. Means concrete may not reach at the bottom. So that one has to ensure. This is very, very important for RMC to placing an order. One has to give all these detail to them. So when you talk about mixed design, that time we'll discuss in detail again. But as a QC engineer, all quality head or executive team head, he has to understand this. Accordingly, he has to place the order with RMC. So fresh concrete, if you are not able to get the fresh concrete properly, there may be huge problems in the structure. Vibration is the issue. You may not get the good finish. All these issues may come whenever there is a issue of workability. Now there's some see earlier how they are you can see 1929 how they are using the concrete, placing concrete directly from the chute, but there's a mechanical means were not there that time. This is for roads directly from transit mixer we can add, because of this slump is limited here. But same concrete not possible for pavers. When you do the PQC, this is not possible to have such a high flow because paver is moving continuously, moving with the time. So this is one fixed form is okay. All fixed forms are there. We'll have about 80 to 100 slump, not more than that. So how to handle, how many people are there, vibrators are there. Accordingly, you can have a placing time of concrete. Somewhere we can use buckets because only small columns are there or capitals are there of column where it's very difficult to pump. Because pump requires certain minimum quantity. So there we can use buckets. Or the bucket also require different workability requirements. Without segregation, you can place this concrete. See here. Crane and bucket is there. And they are placing by, because small house, they can use instead of pump, they can use only bucket. This is 1 cubic meter bucket or 0.75 cubic meter. Today we are getting very big bucket also, 1.5 cubic meter at a time. We can place the concrete, especially for vertical elements. This is also pump they are using because there is no approach here for TM directly load into the transit. So they are using pumps here, but with very minimum flow. One has to remember pumping may not require very high flow. Even about 60 to 80 slump also we can pump the concrete if it is designed properly. Pumping also required to be designed concrete for pumpable concrete. Normal concrete and pumpable concrete, totally different mix is there we have to design. We cannot normal place concrete which was shown for buckets. We may not able to pump it because pumping required different mix proportioning. Rather fines content and has to be adjusted. So if you have very high flow, is also sometimes may not pump properly. So pumping concrete is different than normal manual placing concrete. So one has to remember this. How this earlier photograph I showed, directly we can go into the base and download your transit mixer. Now because of certain configuration and site condition, not possible. Now here they are using placer boom. Sometimes they can use stationary pumps. They just lay the pipeline and here, see here, this is the transit mixer. They are placing it and through this, it is coming to placing point. This also see here, they are doing very large industrial flooring using pumps. Here, this is a TM. You can put into the pump hopper and with this pipeline, it is going to put the concrete here. One advantage is there with this is because very minimum manpower is required. You see, this is a vibrator chap. This is only holding the chute here, pipe, and this is your paver, the leveling equipment. This is also laser based leveling equipment where you need very precise leveling of your floors. Generally, for wherever you are very big warehouses, their, their height is more than say 10 meter, 20 meters. There they required a very high level to the floors. So there they use mechanical means, laser based paver or leveling equipment to have a proper precise flooring. Here also you can have, here see here, this is your belt conveyor you can use for placing concrete. At the end there is a chute. So small, maybe about 10 meter, 20 meter height, 10 meter or 11 meter rather, we have a conveyor belt. Now conveyor belt mix is also totally different than normal pumping, because here pushing is not there, it is going conveying the concrete. So you should not have very high workable mix for this. So all your workability of your concrete depend upon your paste properties of your binder. That one has to remember this. So we have slump cone normal for concrete. We have mini slump cones for mortars. This is for mortar, this is for cement paste, and this is for cement paste. So when you are working on laboratory, you work out this as a quality control tool, and then we can decide or we can predict properties of concrete when you are producing on large scale. So this is how flow table comes. This slide I show because we have to understand the first paste properties, and from paste properties itself we can predict what will be the slump of that concrete. So that one has, because everything is depend upon the viscosity of your mix. Now viscometer is also available, but that is very high cost. But those are also possible to predict the final flow of your mix. So one of the properties what we are looking at all concrete is your cohesiveness. This word one has to remember as a QC engineer or placing engineer. It's the measure of ability to resist segregation on its constitute during handling, placing, and compaction. So this is a processing we are following for any concrete. Any concrete has to transport, then handle, place, and then compaction, and then finishing. So this is the process we follow for all concrete. So your concrete should be cohesive only, not non-cohesive. You see here, coarse aggregates are here and fine paste is here, which is not acceptable. Even here also after compaction, what happens you can see here. It's only paste and coarse aggregate at the bottom. Now this will shrink and then start cracking. Though it is cohesive, once after vibration, it has everything has settled down and segregation has taken place. So one has to design a concrete such a way that my concrete throughout its placing time should remain in cohesive state. That is very important. Now resist the segregation called workability. Basically, see, ease of placing, conductivity, finishing, freshly mixed concrete, and degree of which resist the segregation is called workability. Now workability includes consistency, because it should be a consistent product. Number of TM you are supplying, maybe suppose 100 cubic meter you are supplying, maybe 15, 20 TM. So all concrete should be a consistent workability. Consistent in the sense with the acceptable range. The slump is there, suppose slump is 120 plus minus 20 mm. It should not be 80, 60 mm and then it is may not be 200 mm. That is not acceptable. So one has to remember accordingly. Segregation, cohesiveness should be there. Mobility, because some concrete you will find is a workable. It is very difficult to place by the vibrators. Is not responding to the very sticky mix, which is not acceptable. Very sticky mix. Maybe is a due to the various reasons that we'll discuss when you're talking about mixed designs and other properties. So mobility is important because it has to move very easily with minimum amount of external efforts, that is vibration or consolidation we can say. So that one has to see very carefully and design the concrete accordingly. Because various component of your ingredients of concrete is affecting the workability. So one has to remember that and accordingly we have to act upon. Most of the time what is happening at site is people are adding any stiffness is there, they go on adding water, which is not advisable. Technical advisor will not allow you to add any water at the site, which will reduce the or drastically change the properties of concrete, which is not acceptable as a structural engineer or as a concrete technologist. So one has to very careful. Pumpability. As I said earlier, pumpable mix has to be designed properly. In our engineering, the pump operators who are operating the pumps, they are not exposed to the concrete properties. They know only mechanical part. So most of the pump operator, whenever there is a flow down, he'll add to the water and they get more pump chokes up. You do not add water to make concrete workable and then pump. As I said earlier, pumpable mix means may not be a flowable mix. You have slum mix also can be pumped very effectively if it is designed properly. You can see here the mix. Very smooth mix is moving up. So pumpability, we have to design a mix. So when we are designing concrete mix design in that session, we'll discuss how to design a pumpable mix. Why it is required. What is its real requirement. Then bleeding. Bleeding some part I think we have discussed. Bleeding is nothing but when you have finished the concrete, clean water coming on the surface of your concrete and that layer, water layer is called a bleeding. Now this test also we can conduct whenever you're doing mixed design in the laboratory. Once you have frozen your mixed proportions, frozen for the particular workability and for particular strength, we can also check for bleeding, whether my mix is bleed or not. If his bleeding is there, what action to be taken, we'll discuss later. But concrete should be free from bleeding. And also needs to be a very good finishability. It's very easy to make a finish, you can see here. So that one has to check in laboratory itself. So when we are designing in laboratory, we'll find whether my concrete which I designed is bleeding or not bleeding. Those tests are given. We'll discuss that, how to test about bleeding. The degree of workability required control by placement method. As I said earlier, if you do direct placing, you require different flow or different workability. I do by pumping, I need different. If I do by crane, I require different workability. So Workability depend upon your placing method. Type of consolidation, what type of consolidation we have, mechanical vibrator, internal, external, or only by manual modes, only by rods, and type of concrete. Type of concrete, you have precast concrete, you have in situ pile concrete, or you have high flowable concrete, or you have a PQC, pavement, sorry, pavement quality concrete, where we required very, very low slump, maybe in the tune of 25 to 30 mm. It is if you are using paver. If you are not using paver, you are using fixed form for the roads, you may require about 80 mm slump. Is sufficient for that. But suppose you are doing a column where your depth is more than 4-5 meters, you may need high workable mix. But that is it. So depend upon the type of concrete we are going to use, you can design a concrete accordingly. So these points one has to remember as a when you are designing in your concrete in the laboratory. There is a request come from the project site. I want this concrete only grade, but then you have to ask these questions to them. How you are going to vibrate this? What is the placing method we have? What will the ambient conditions are there? That one has to understand, and accordingly you design a concrete. Otherwise, whatever concrete you have designed may not workable for site.